Hello, everyone. It's been a little bit now, but not that long, not as long since my last videos. But the thing I wanted to go over today was, I have my new laser all set up and running at this point in time. And now that I've gone through all the pain and the suffering and the tears, we're finally at a place where I think I have something that I can start to call success. No projects yet, but that's besides the point. So originally on my other laser, the one that I had gotten rid of, these were the sort of tests that you get, well, that you do when you're just seeing the power of the laser and how fast you need to travel. So, you'd start off fast and increase the power, and then, and down here is slow and higher power. So this scale is higher power, this is speed, so higher speed, higher power. Same thing, but one's engraving, one's cutting. So this is an old test, and as you can see at some point in time, like this is the cut test. You can see some of them cut through and some of them don't. And you can see how clean they are or not on the back. So this thing did a pretty good job on this particular wood. And so I have a similar one in walnut for that laser. So what I had gotten into was that originally when I first bought this laser, the mirrors were horrendously out of whack. So you have to focus the beam of your laser into the exact center of each mirror, and then that has to then drop the laser down at a perfect 90-degree angle so it can hit the material properly. And if there's, you think about it being in a tube, if it hits the side of that tube, it distorts your laser and you don't get a good cut. So that was what I originally ran into, and it was giving me absolute dog shit. So I went through a whole different series of tests, and one of the first series of tests that I got to after I finally got the laser focused was basically like a depth. Like how far away should the nozzle of the laser be from the material? And you can see right in here it starts to actually get this really tiny clean line, and that's where you want to be when that's telling you're at the focal point of the laser where it's the most effective. So this kind of told me how deep I needed to be. It was like, the measurements aren't really important. The important part is the distance of the nozzle. So I made a piece of wood that, I sanded it down. This one's a little bit tapered, so it actually gives me a different measurement here, and then I can just like increase to the end. And but here's about where that measurement lands. So I just stick this in under the nozzle. I stick this in under the nozzle, and if there's a piece of material there, I basically get this nozzle to touch that piece of wood, and then I remove that, and now it's at the basic focal length that I need it to. Now, I had made some mistakes along the way. As I said, I had done that test, and I thought, oh well, I'm good. But then I came back and I did a broad test, and I thought, wow, that looks like garbage. It's all burned, and the holes are all a little wide. I thought, well, maybe I'm not doing a cut test. So I went here, and it's pretty much the same travesty of like these lines just look extremely thick, and then you can see down here it doesn't look. It looks like I set it on fire, which is pretty much what happened. And this is at full power down here, which this laser is literally almost double the power of this laser. And so these are about the same feeds and speeds. So you can see that something is just terribly wrong if my laser that's about half the power is beating my laser with double the power. So something was really wrong there, and I was a little bit mad. I thought, let's try it on a different wood. So this is like a known piece of wood that I'd already tested, and I had done the engraving test on this side, so I just decided to flip it over and see what would happen if I did the exact piece of wood. So I have a direct comparison of this one to this one, and sort of the same story where it just was giving me really thick cut lines. And today when I came in, I realized that I'm an idiot, and I was measuring my piece of wood that way, and so that pushed my focal length further out. And then today I did it properly, ended up with this. So this is where is it? What the hell happened to it? Oh, right here. Pretty much the same tests. You can see this one was even cutting way up here at the faster speeds and almost the lowest power. So I could probably go even lower power than that, but massive, massive difference. And this is so much cleaner. So finally getting somewhere, but that's good. I'm happy to report that it's finally working. This laser, so the thing you don't ever really get to find out without knowing anything about lasers is lasers can get extremely expensive, and knowing what you're buying, one laser might look exactly like another laser, and it might have the same features, but they're completely different beasts altogether. So knowing what I know now, so this machine behind me probably cost me on the order. I mean, as said and done, all said and done, I mean, okay, so the machine itself cost it was $3,800. That's shipped to my door. That's all the shipping and taxes and everything everything after the fact. But that's not where the costs actually end, because this machine is actually quite a bit shorter than I thought it was going to be. I thought it was going to be a bit taller than that, but it's fine. That's not the problem. So, I had to go buy plywood and materials to get it lifted off the ground. That adds another $100. I rigged it up so I have, I'll actually show you. It's pretty interesting, actually. So I ended up having to buy a new air compressor, and then there's air that came back out and over, and I have it rigged up to a blower fan there. So all of that ended up costing me probably about another $500 or $600 just in bits and pieces that I needed to buy, little air fittings, the hoses, and so many things that I just never anticipated. Well, okay, so because I kind of went into it trying to, get it up and running as fast as possible, but that was a little bit, little bit longer of a runway than I anticipated. But if I know what I know now, I probably would have gone with a different machine. But now that it's working, I have no problem with it. It was all about the the pain and suffering of going through actually getting it running. So anyways, I don't know if I mentioned this in the last time, but I completely redid the spoil board on this machine. That was a whole process in of itself. Just getting all these pieces laid out. I mean, you think about this, there's probably about over 150 fasteners that I had to do by hand in all of this. I mean, I didn't drill them by hand. The machine actually drilled all the holes and the locations, but I still had to design everything and set it up and get everything divided so it's all even and well set up. So that was a whole saga of heartache on its own. And all while I was doing that, I was working on that guy too. So it's been a bit of a mess around here lately, just with me trying to get these two machines to where I want them to be in terms of their functionality and ease of use, and you know. But I guess I should go into more of why I went through all the process of setting all the things up with that. So the stock blower fan was a tiny little blower fan, and the stock air assist, which is again just a little tiny pump, and it barely, farts out tiny bits of air, whereas the air compressor can push out larger volumes of air. And especially when you're cutting thicker materials, you need the larger volume of air. So that's why I went to that. But the tiny little fan that's in the back of that, it creates a positive pressure. So if you think about blowing up a balloon, the balloon wants to fly away from you, whereas whereas the putting the exhaust way over at the other end creates negative pressure, where it's actually sucking the air. It's almost like sucking the air out of the balloon. So it wants to squeeze the balloon smaller, and that's really what you want when you're trying to extract exhaust, like the smoke from the building, because I don't want to breathe that in. So that was a whole deal too. Oh, by the way, you have to ground these machines because you go up to like a higher wattage. The tube is actually about the entire length of the machine. Actually, you can see on the back of the machine, it even sticks out a little bit. So the tube is almost 5 feet long, and because of the fact that you're using the laser tube, it creates all sort of electromagnetic interference with things, so they have to be very well grounded. So you actually have to run separate grounding, and I had to go through a whole series of testing the ground in this building because I know nothing about this building or how any of the outlets are set up. So you have to make sure that you have a real ground that actually goes back to the panel. So I had to run 150 feet of wire over to the panel and make sure that it's actually grounded properly. So the machine's also properly grounded. But all of that takes time, and me being the only person here in the shop, I have to do every single little one of those activities. Getting because this is a cheap Chinese laser, nothing against the Chinese, but when you pay less, they do less. It's just how the world works. So the way they had it set up when they sent it to me was suboptimal, and I had to do a bunch of work. I took some skin off my knuckles, adjusting the table in there, because this front corner over here was probably about 3 millimeters lower than the rest of the bed for some reason. So I had to go and I had to literally bleed to get that to function properly. So it's been a long road just for that. I mean, in the grand scheme of things, it really hasn't been that long. It's only been about 2 weeks. It feels like an eternity. But I'm very, very happy to report I finally have a laser that does things, and I didn't spend my money for no reason. So yeah, more to come on all of that. Thanks. Bye.